Hi, Simon here, GM8NYV. Just a little update on the CR100. Last couple of weeks I've done little bits and pieces to try and iron out some of the little silly faults I had come across. Well, this is it upside down. It's actually sitting on a plastic box on top of the tuning capacitor, which is closed obviously. I haven't put the dial on yet, not until I get it working perfectly. And then I shall start to put the dial on and get it tuned up. So I'll just pause there and I'll zoom in zoom in at the switch. I'll explain that in a minute. I'm not sure how this is going to show up on the cam, this angle. If I zoom in a bit, maybe see a bit better. Right, the problem I had originally was the shaft that runs through all the switch wafers had split down the middle, and it wasn't lining up. Well, it was lining up, but there was a lot of play in it as I moved it. So I found a solid bar, which I had for ages. This one. So I tried a solid bar in it, and then I discovered that it still had a lot of play in it once it was installed, unfortunately. So I decided to put the split bar back in after researching it on a few websites, and other people had this problem before and they've written to me and told me what they've done. So I put the split bar back in. That was something to do with modification by Marconi using the split bar, because it didn't line up, the wafers weren't lined up with the actual shaft band chain switch. So in order to relieve the strain, because it would have been at an angle on the switches, they split the bar down the middle, but then they put little screws in it. I'm not sure if you can see the screws here. They used grub screws, but I couldn't find any grub screws. But I managed to find old screws from an old radio that I had spare, and they actually fitted the same thread. They're not metric threads, I'm not sure what the thread is. So I'll zoom in a bit more, you might see it. So, if I rotate the switch there, you can see it here maybe. Right, that's just one, and there's one either side of each switch in each coil pack. So I managed to find 8 of them. Now to get them right, I had to look at the wafers on here and make sure it was in the right position on each wafer. It had a lot of play on it, and then tighten up the individual screws, and it's working quite well. It's doing exactly what it was supposed to do. So there's no play now, and I can rotate the switch through the 6 bands without it going out of alignment. Right, the other problem I had that I hadn't needed to sort out was the BFO. This is the BFO here. It's a valve here, it's an oscillator. Now then, the BFO wasn't operating at all, and I checked the valves and the obvious things, and in the end I thought, I'm going to have to take the can out off. And one of the things I found was on the variable capacitor in here, there's a variable capacitor that rotates. The moving vanes weren't connecting, very loose on the shaft, and they weren't really connecting to the shaft, which is there. That was one problem, but that wasn't the main problem. On closer inspection, the bottom on the coil on here, one of the windings on the inside on the coil, it went through some small insulation, and it had been joined and it had come apart. It didn't look like it had come apart, but when I unsoldered it, the rest of it fell out, so I had to rejoin that. And since I repaired the bottom of the coil, then it's starting to work okay, so quite happy with that. Now the other problem was, the obvious problem was the shaft not aligning with the wave change. But after I did that, I found that band 6 wasn't working, and I noticed there was I had the oscillator valve in. It goes in there, and I noticed there was no oscillations. There wasn't oscillation on band 6 anywhere on it. So again I had to turn it over, and doing some resistance checks I found out that one of the oscillator switch, there's 2 switches in each set of coils, and on the oscillator one, I'll see here, the unused coils are earthed through this switch. This is the one that selects the coils. Now then, on band 6, the one that earthed out the coil shouldn't be earthed at band 6 point, but when you rotated the switch in one direction, the actual lug on the switch moved. It was riveted to the switch wafer, and it actually started to move, so it moved out of alignment, and it didn't when I moved it back to the position 6, band 6 position, it was still earthed. It was still earthing it out. So I had to take the coil pack off again, so I was spinning it out a few times. To do that I had to unsolder the wires here, and obviously turn it over and disconnect the wires on the inside. But it's quite easy, you can get single coil packs out. Having realigned all those little screws for the wafers, I had to take them out again to slide the shaft out. So it was a bit of a nightmare to do all that, but I got it done, and I discovered that, as I say, the rivet had come loose on the lug, so I managed to squeeze up the lug, squeeze up the rivet so it doesn't move, and I put a small drop of super glue on it so it doesn't rotate. Reassembled it, and now I get every band working. So time consuming, but that's the way it is, I suppose. Right, once I had all that done, I thought I'd give it a test again, and it seemed to perform a bit better. On band 6, it wasn't so sensitive, and I was looking around at the oscillator valve. When you get oscillations through every band, except when you got to band 6, obviously it does say that in books and a lot of write-ups that the oscillator starts to drop off at the higher end. So I started measuring the actual amplitude of the oscillator circuit on the different bands, and trying different valves in to see which one gave me the best results. Now, there wasn't, 1 or 2 valves were really bad, and I found a couple of good valves that did give good oscillations, and I thought, wonder if I buy a new one. Well, I've managed to get a, what do you call it, new old stock, and I put that one in. So I'll just show you the difference between the new old stock, which has never been used apparently, and the ones that came with the radio. Right, I've got it set to band 6. Just going to compare a couple of valves here. I've got the rectifier in, obviously, and this is one of the old valves. It's I just picked it at random. I didn't mark them, so I don't know which is. Some are worse than others, so I'm going to try this one just to compare this with the new one. But I know the new one is much better than all of them, so I'll just put the oscillator in and put my scope on here. Right, so we're set to band 6. I'll switch it on. It should heat up. Give it a second or two. And the HT is not on, so I'll move the cam so you can see the scope up there. Hopefully, I have to zoom in a little. You not really see the. But this is all the readings here. It's not coming up too well, but you see the thing there. So put the HT on. Right, I've got it set to band 6. The tuning capacitor is about the centre, and it's oscillating around about 17 megahertz at the moment, and it's giving a very small signal there. This is band 6. Band 6 is the worst on any valve, but this is one of the original valves. You can't read it here, but it's reading 1.68 volts peak to peak on that waveform there. I mean, as you turn it, obviously it does work. So it's on about 17 megs there, 17 megs oscillating at. And I've got a peak to peak of 1.68 volts on that valve. I'll switch it down to band 5, a much bigger waveform now. Obviously it's now on band 5, it's running at 6.5 megs, and our peak to peak is 4.6 volts. So there we go. Right, I shall now swap the valve. Right, okay, this is the new old stock, as I said, CV 1100 written on it, but it's KTW62. Open this up. It's a GT. It's slightly different shape. So this is it. This is new old stock. Apparently it's never been used, and he tested it, it was okay. So that is my new valve there. It's more tubular than the other ones. These are the originals here I was using. There's a new one. So the new one in, we'll see how it differs. There. Okay. Right, power it up. Got a capacitor to warm up. Turn the HT on there. And on the scope. Now we're on band 5 still. So on band 5, the last voltage was about 4.6, wasn't it? On this one, 5.36, so it's higher by about a volt. Now I go up to band 6. Again, it's still on 17 megs, and we've got peak to peak of 2.2 volts, where that old valve on that band was at 1.6, 1.7. So it's a little difference, not a big, huge jump. I went through them all. I mean, this valve here, the one I just tried before the new one, wasn't. It's not the best. I went through them all, but I didn't mark them, so I don't know which is which. But there are worse ones than this. So there we go. So not bad for £9 on eBay. £4.50 postage. He's got a few more, so I've ordered up more to replace all of them with the new old stock. So a complete set of new valves, as in they've never been in use. Right. The next thing that I want to mention here, I can see that very well on this tab. I downloaded Practical Wireless. This is Practical Wireless. So that's 1987, January 87. Practical Wireless, and on it was a design for a wobulator. This is the picture on the front here, designed by R.A. Penfold. He's retired now, but I think he's still there. He still writes a lot of electronic books and maybe still a few articles for magazines, etc. Right, on one of the pages, it doesn't come up very well on the camera. So that's the design of Practical Wireless. I'll just download onto the tab here. Put the circuit board at the top. Circuit at the bottom there. Anyway, it's not very good showing you on the tab. What I've got here is the one I made. Put it in a little grey box here. There's the three controls. One's the amplitude output, one's the actual centre, frequency centre, and the actual width, bandwidth. The circuit board I made a print circuit board the same as this, but unfortunately it was too long to go in this box. Fortunately, when I looked at it, the actual part that was too long had the output transistor and a couple of Zeners on it just to regulate the voltage, so I chopped that bit off and instead I've used a voltage regulator on a separate board. So this is roughly, now I reduce that. So that's the board there, and I put this little voltage regulator in here. Now originally R.A. Penfold ran off 2 9-volt batteries, 18 volts, and he dropped it down to 10 using a Zener diode and a transistor. But I put a little DC plug in here, so I'll probably run it off from the power supply here. So this modulator will be used for setting up the IF stages. The only thing it's not really calibrated. I need to find some way of calibrating it. I've also put an on-off switch at the back. I've left another hole here with a pot. So what I might do is disconnect the sweep side of it and just put the pot directly onto it so I can center the frequency. So I can make a mark on the scope where that is. I'll just vary the voltage on the this is a VCA, voltage controlled oscillator, VCO. The 4048 chip, a 4046 CMOS. NE555 produces this NE555 here produces the sawtooth. The voltage it goes up about 2 to 5 volts, I think, and that is then controlled by these two op amps. That's a dual op amp to set, so we can set the frequency center and the actual sweep rate. It's then passed on to the voltage controlled oscillator, and the output is taken. I had these two BNCs, I don't know what they were, so I sort of utilised them. I think for a stereo or something, so I've stuck them in and utilised them. This one here takes the trigger output, so when it starts with the sweep, you get a trigger pulse sent out to the scope. And obviously the output will then go to the first IF input of the radio, and the output after the demodulator, after the demodulator will go into the scope, and hopefully we get a response shape of the IF, and should be able to set it up using this. So there we go. So I might just make a front panel, print a front panel for it when I get around to it. So that's how far I've got. So the next thing is to try and test it with the regulator. Right, that's all I've done for now. As I've ordered more valves. I still got the noise limiter to wire up properly. You see the pink cables that are on the radio there. That needs tidying up and sorting out properly. Happy the BFO works and everything else works. It's just a matter of tuning it up. I also noticed it's quite insensitive at the ends of the tuning side. You know, either when the tuning capacitor is fully meshed or fully open, so the band edges. So it's probably needs the coils tuned. But there's no bass on this. Now I read somewhere that the bass does affect the tuning, and they surmise that in the original factory when it was set up, they had a metal plate, a dummy plate went on the back with holes drilled in it, so you can access the coils. And once it was tuned up, they'd take that one away and put the proper plate on it. Now I've got an old dishwasher I was about to take to the dump, so I'm going to cut the side off and make that into a dummy plate, drill a few holes in it. So hopefully that's another project to do before I set it all up. Right, okay, thanks for watching. That was a quick update. Bit slow progress. I've been busy with other things, and but it's nice to get this sorted out. It'd be really nice to get the front dial on and to get this redone, the tuning scale, get that all sorted out and all working. Right, okay. Thanks for watching. Hope you liked it, and catch you next time. Bye bye.